Good morning, students. We'll solve numericals on phase rule. So please go through this numerical, read once. So we'll discuss afterwards. Okay. So after reading, we will draw that first phase rule diagram for two component system, and then we'll proceed. Okay. As per the numerical, what they are given, we will read first. An alloy of zinc and cadmium contains 83.5 percentage of zinc. So we'll write first uh, alloy composition. So it will be, so alloy composition is equal to, that is Zn plus cadmium. What they have given, 83.5 percentage of zinc and 16.5 percentage of cadmium. Okay, so because it is 100 total, so 100 minus 83.5, so it means that you will be having 835 grams of zinc and 165 grams of cadmium. Okay, because what they have given, 1 kilogram of alloy, this is given. Okay, so 1 kilogram means 1000 gram. Okay, any doubt up till this? Now what they are given other things also, eutectic composition given as 67 percentage of Zn. So obviously the remaining 33 percentage of cadmium. So this will be the eutectic composition. Okay, so if you want to draw a rough diagram, so how will you draw? So this is a rough diagram. What I given, suppose this is temperature and this is percentage composition. In exam, no need to draw this diagram, this is just for your understanding, but if you draw diagram roughly, there will be less chances you will go wrong. Okay, so temperature and pressure, we are not interested in temperature, we are interested in composition. So what I given is, suppose this is, let's say 0% Zn and 100% Zn. This is 100% cadmium and 0% cadmium. So if you want to draw plot this particular diagram, so what they have given is alloy composition given is 83.5 and 16.5, 83.5, of zinc and 16.5 of cadmium. So where it will be, the point will be in the diagram 83.5. so this is 0%, so obviously 50%, so it is here approximate 80, let's say 83.5. so suppose this is 83.5 percentage Zn and 16.5 percentage cadmium. Okay, and so this is the alloy composition. So this is what, alloy composition. Now what is eutectic composition? So eutectic composition they are given is 67 and 33. 67 zinc, so obviously this will be 50 and less than 83, so somewhere around this point, this is 67% zinc and remaining 33% cadmium. So this will be eutectic and this will be alloy composition. Okay, so alloy composition nothing but 1 kg or 1000 gram. Okay, now you can plot roughly diagram this way. So point belongs to, so alloy composition or alloy belongs to this region. So this region will contain what? This region will contain what? Since this is 100% iron, so this will contain, this region will contain solid eutectic plus solid Zn. Understood? So question will be, what will be the total mass of solid eutectic? What will be the mass of individual eutectic due to Zn or due to CD cadmium, or what will be the total weight of solid Zn in the particular region? Okay, if they ask what is the total weight of solid cadmium in this region, then it will be 0 gram. Okay, because all cadmium is been forming eutectic. No solid CD will be present in this particular region. So therefore you need to draw this diagram to get exact idea about what will be the present in the eutectic, what amount, and what is not present or precipitated as a particular metal, okay, or element. Okay, so that is the idea. So this is you can say roughly you can say the given data. Now we will solve. Okay, so we'll go further. So this is our first sheet. So now we'll just look here. So what they are given, let's say eutectic composition you will write first. So this will be the 67% of Zn, 33% of cadmium. So you can write this is the eutectic composition. Okay, so it's equivalent. As I told you just now, all cadmium will go and form eutectic. No solid cadmium will be present. So what is the weight of cadmium in the alloy? It will be 16.5%, or you can say 165 gram. So all cadmium will go and form eutectic. So this is the composition of the eutectic. Cadmium will be present in the eutectic composition. So corresponds to Zn 67% out of 835 gram, because what is Zn? 83.5% or 835 gram, okay, of the total, out of total alloy. Okay, so out of 835, what amount of Zn will go and form eutectic? That will be corresponds to cadmium. So that will be the first step. So you can write, so this is the equation. So cross multiplication and you will find out x. So therefore x is equal to 165 into 67 divided by 33, and just calculate that. It will be around 335. Just cross check. 335 gram. Okay, what do you mean by this? Out of 835 gram of Zn, 335 gram will go into the eutectic, so total weight or mass of eutectic will be due to Zn plus due to cadmium. So due to Zn it will be 335 gram plus due to CD 165 gram. So it will be around 500 gram. Okay, so total eutectic will be 500. The question will be like this: what mass of eutectic, what mass of Zn in the eutectic? So it will be 335 grams. If the question is what mass of cadmium in eutectic, it will be 165 gram. The question is, if the question is what total mass of weight or mass in the eutectic, so it will be 500 grams. So individual as well as total. So that will be the first question. Okay, any doubt up till this? Okay, now I told you with respect to this diagram, see, this point corresponds to total alloy composition, and this composition is eutectic composition. So 83.5 and 16.5 will be present in the alloy. So out of 835, 335 gram will be going into the eutectic. So what is the remaining solid? As I told you, this region consists of solid eutectic and solid Zn. So this solid eutectic, nothing but what? This is due to Zn plus due to CD. and this is nothing but 500 gram. So what about Zn? Okay, solid Zn. So it will be, so now solid Zn, the crystalline Zn will be total weight of Zn in alloy minus Zn or mass of Zn going into eutectic. Okay, so total will be 835 minus 335, so it will be 500 gram. Okay, so it means solid eutectic 500 gram and solid Zn will be 500 gram. So see, 500 plus 500, 1 alloy, 1 kilogram alloy, and out of 1 kg, as I told you, due to CD it will be 165 gram, and due to Zn 335 gram. So total 500 gram will be going into eutectic out of 1 kg, and 500 will be forming as a solid zinc. So there will be no solid cadmium, 0 gram of solid cadmium will be present in this particular region. Okay, so remember this example and remember this particular diagram, and this will be your final answer. So the question will be like this: weight of the Zn in the eutectic, weight of the cadmium in the eutectic, total weight of Zn and cadmium in the eutectic, then solid solid Zn or solid cadmium. Okay, so if you have any doubt you can ask me. Thank you.